Saturn V Quarterly Film Report Number 6 covers progress during the period March, April, and May 1964, highlighting Saturn ground test stage construction. Prime contractor for the S-1C is Boeing Aircraft Company, responsible for fabrication and assembly of 10 of the 14 presently scheduled S-1C stages. The remaining stages are being or will be assembled by Marshall using Boeing-supplied components. S-1C efforts at Marshall this quarter were primarily in support of the test fuel tank and the static test stage. On March 6th, the test fuel tank was removed from the vertical assembly building where the forward and aft adapters had been attached and was moved to the center's structural test area. Here, the tank was placed in the test stand and preparations began for the structural testing, which is scheduled in June. The first phase of the test program will be a full-pressure hydrostatic test. Slash, vibration, and burst tests will be conducted later. Assembly of the S-1CT static test stage continued to progress during the report period. The upper half of the fuel tank was moved into the vertical assembly building in early March and hoisted temporarily into the hydrostatic tower. A week later, the lower half of the fuel tank was moved into the VAB and positioned on the rotary turntable. In mid-April, the upper and lower halves of the S-1CT fuel tank were welded together. The first of 5 LOX tunnels for the S-1CT fuel tank was installed in mid-May. The fuel tank had been moved to the hydrostatic tower for this operation so that the vertical assembly building's rotary turntable would be available for work on the S-1CT LOX tank. Completion of LOX tunnel installation is expected early next quarter. The lower bulkhead assembly of the S-1CT LOX tank was completed in late May and moved onto the rotary turntable, where the lower intermediate skin section will be welded to it next quarter. The LOX tank differs from the fuel tank in the addition of 2 intermediate skin sections. Welding on the upper bulkhead assembly was completed near the end of this report period. Following welding of the upper intermediate skin section to this assembly, the upper and lower halves will be mated in the vertical assembly building next quarter to complete the S-1CT LOX tank. Installation of the 16 skin panels on the S-1CT thrust structure has now been completed. Installation of the heat shield is scheduled to begin in June. Component hardware for the S-1C structural test stage is being received at Marshall from Boeing, and fuel tank bulkhead fabrication is underway. Construction of Marshall's S-1C static test stand continued during the quarter. Completion of initial construction is expected by the end of this year. A full-size mock-up of the S-1C stage, 139 feet long and 33 feet in diameter, has been built by Boeing at Michoud. The size, angle, and other measurements of tubes and wires will be determined from the mock-up and the information used in production of flight stages. Bulkhead fabrication work for the S-1CD dynamic test stage is underway by Boeing at the Michoud plant. Fabrication of other S-1C components continued during the report period at Boeing Michoud and Wichita. This cruciform baffle, for example, was manufactured for installation in the lower fuel bulkhead. These propellant line support structures are used to support the LOX tunnels in the thrust structure. This adapter fitting will serve as a terminal fitting for one arm of the engine actuator support assembly and as the attach point for the solid propellant retro rocket. At the Seal Beach facility of North American Aviation Space and Information Systems Division, S-2 manufacturing activities progressed steadily during this report period. The forward liquid hydrogen bulkhead for the S-2S stage was hydrostatically tested and satisfactory helium leak detection tests were performed. Subsequently, the bulkhead was cleaned and acid etched, then turned over in the turnover fixture to apply protective coating to the dome. On March 30th, the bulkhead was transferred to the vertical assembly building and positioned over liquid hydrogen cylinder number 6. During May, the bulkhead and cylinder were joined together by a circumferential weld. In fabrication work on the S2S stage common bulkhead, all meridian welds on the forward-facing sheet have been completed, the dollar section installed, and the bulkhead hydrostatic tested. Meridian and dollar section welding was also finished on the common bulkhead aft-facing sheet for the bulkhead test tank during April. Liquid hydrogen tank cylinder fabrication for the S2S stage continued this quarter. During April, the quarter panels of cylinder number 4 were joined by vertical welds and the assembled cylinder was circumferentially trimmed. Vertical welding was also underway on quarter panels for cylinder number 5. At S&ID's S2 stage propulsion test facility at Santa Susana, construction of the battleship stage and Coca 1 test stand is complete, and installation of systems will begin next quarter. The Coca 4 all systems test stand construction effort is also complete, and the 60-ton capacity hoist is operational. At the beginning of this quarter, the S4B hydrostatic and dynamic test stages were in Douglas Aircraft Company's vertical assembly towers at Huntington Beach. The hydrostatic test stage was later moved from its assembly tower and placed in the structure's test building where strain gauges and other instrumentation devices were installed in preparation for the start of hydrostatic testing next quarter. In assembly work on the S4B dynamic test stage, welding of the LOX and liquid hydrogen tanks, as well as internal welding of the forward liquid hydrogen dome to the liquid hydrogen tank, was completed in mid-March at Huntington Beach. During this report period, the S4B all-system stage was processed through assembly towers 1 and 2, where necessary welding was accomplished and was installed in the hydrostatic tower. At Douglas's Sacramento test facility, satisfactory final inspection of facility contractor effort at the Gamma Complex Test Control Center and Instrumentation Center was performed March 25th. At SACTO's Beta Complex, installation of instrumentation at Beta Test Stand number 1 is continuing, and cold flow testing of the battleship stage is expected to begin in June. At Beta Test Stand number 3, construction continued during the report period with completion scheduled next quarter. The stand will be used for test programs with the all-systems stage. On April 21st, at the rocket engine test site, Edwards Air Force Base, during the informal PFRT on F1 R&D engine number 019, a LOX pump explosion occurred at 111 seconds into the run. The test stand suffered damage similar to that which occurred during the previous pump explosion on engine number 014 in February. Approximately 3 weeks were required for stand repair. As a result of the April explosion, all engine system and turbo pump testing with LOX was halted, while a team composed of members from Rocketdyne and Marshall conducted a thorough investigation of the matter. Testing was resumed May 15th after incorporation of recommended changes. Production test stand 1D at Edwards was completed this quarter. Work on stand 1C is in its final phases. Stand 1E activation is due in the fall. The control center at the production test area is now well over 2/3 finished. At the Marshall Center, prior to the April 21st explosion at Edwards, Propulsion system testing of the first F1 production engine continued with 5 firings for a total main stage time of 196 seconds. The second production engine was delivered to Marshall by Rocketdyne on April 1st. Quality Lab completed its receiving inspection on April 14th, and the engine was delivered to Test Lab where it is undergoing pre-test preparation. Overall construction of the F1 engine static test stand at Marshall has reached 80% completion with beneficial occupancy due next quarter. Rocketdyne's first J2 production engine was accepted by the Marshall Center this quarter. The engine was turned over to Douglas Aircraft for use in captive tests associated with S-4B battleship stage work. A series of engine system static tests was conducted during this report period to demonstrate full gimbal capability, as well as safety limits, malfunction, and full propellant utilization valve operation prior to entering PFRT. The engine was gimbaled twice to a 7-degree limit in 4 different planes with 3 passes in each plane, and to a 10-degree gimbal angle in the corners on another test. A full-scale mock-up, 260 inches in diameter, of the Saturn V instrument unit was under construction at the Marshall Center during the report period to assist engineers in proving out designs related to electrical cable length and routing, instrument and bracketry fittings, and the IU cooling system. The mock-up is now about 50% finished. International Business Machine's new facilities at Huntsville will be the site of Saturn V IU engineering and checkout work. IBM was selected by NASA this quarter as lead contractor for development and fabrication of the IU. The first computer and computer tester, an early development model of the flight configuration equipment depicted in this artist's drawing, was accepted this quarter from IBM for use in the IU breadboard. Construction of the Saturn V dynamic test stand at Marshall is now approximately 80% complete. Beneficial occupancy is scheduled in August. At Marshall's Saturn V ground support equipment test facility, depicted in this artist's drawing, brick and mortar construction is approximately 35% finished. The technical systems contractor is approximately 85% complete, with all equipment scheduled for delivery by June. Installation of the technical systems is scheduled to start in July. At Marshall's Mississippi Test Facility, construction is continuing under 3 main complexes. The test complex, including excavation and foundation work on the S1C dual position static test stand and the 2 S2 static test stands. The laboratory and engineering complex, which includes the office and administration building, and the telephone and terminal building. And the support services complex, which encompasses such facilities as the emergency services building, the MTF warehouse, the site maintenance building, the central heating plant, and the electrical substation. Work also progressed steadily on the various roads, railway facilities, river channels, docks, canals, and bridges which comprise the MTF transportation system.